Hello and welcome. I am Vishwanathan. In this video, let us try to learn and understand an alternate program for ID3, that is Iterative Dichotomizer 3. Now, a video already exists in my playlist, which is quite long and it is probably considered to be very tough. This is one of the programs which is much shorter and simpler, but there is one thing which we need to remember. Now, as a matter of fact, we must know that we are using this module called Mutual Info Classif from this package sklearn.teacher selection. Now, this program on the whole is not actually something which can be rejected. We are not using any package that directly implements ID3. This Mutual Info Classif is just evaluating the information gains. So it is not in any way directly implementing ID3. So we are not using any built-in function, but we are just using a function which will simplify most of the steps. And the algorithm remains the same. So this is one thing which probably have to be conveyed to the examiner, that the module or the package which we are using is just a thing we are using to calculate the information gain. So that is one thing we must need to remember. Now let us dive into the program without much introduction. The detailed information of ID3 is already there in the other video. In this program, so we basically import pandas and see pprint is like pretty print. This is for printing dictionaries and things like that. So we will understand why this is used. And as I said, this sklearn.teacher selection, here we find this thing called mutual info classif. Now this is a function we are calling in order to evaluate the gains, or what we call as information gain. And from this collections package we import what is called as counter. We will understand what it is actually doing. Now this is the main part of the program where the execution starts. We will come to this a little later. Now we will just understand this ID3 function. So this is the entire program. It is actually very short and understandable. So the ID3 is a function which is taking a few parameters. Let us understand the parameters first. So df is the data frame or the data set, and target attribute is the output column, or whatever we consider in the data set. This is the output column, plate ns. So that will be accessed using this parameter called target attribute, and attribute names is the other column headers, and this default class is equals to none is a initializing we are making for a particular case. So this is something which you need to remember. Now cnd is just a variable. What we are doing in this line of code is we are calling the counter function. Now counter function is present in this collections package. What it basically does is it will see we are traversing the data frame for x in data frame of target attribute. So this is the target attribute. What this line of code is doing is this counter function will basically return how many unique values are there in the column and how many of them are there. In other words, now let us understand. So now plate ns, you can see that there are two types of values, that is it can have zeros and it can have ones. So what this counter function will basically do is it will return so the number of zeros. So it will say 0, there are 5 zeros, 1 2 3 4 and 5, and there are 9 ones. So basically it will return the number of unique values in this target attribute column. That is what is happening in this cnd function. And this id3 function is a recursive one. You can see that it is being called within the function itself, id3. So in the next iteration, the data frame what we pass here, data frame of target attribute. Now we know from the theory that after first iteration we will usually consider a subset or a subtable. So at that time again it will just see the target column, that is the output column. Basically it will just return the number of zeros and number of ones. That is what is happening in this line of code. Okay, now the algorithm is explained in detail already in the video, but let us quickly run through this. Now ID3 is a algorithm. Basically why we are using this is to create a decision tree. Okay, and information gain is what we find in order to estimate, in order to identify the best attribute to perform the classification. So this is the first step. We find the information gain of all the attributes, and the attribute with the highest gain will be chosen as the root node. Now this will be implemented here, but what we are doing at this point of time is, like at this line of code is, if the length of count is equals to 1. Now what does this mean? So if the counter, what if this returns only a single entity, that means if in some data set, if in some part of the data set or in some subset of the data set, if this plate ns has either only 0 values or only 1 values, then the entropy will become 0, and all that theory will come in the algorithm. When we have all the values as 0 or all the values as 1, entropy will become 0 and calculation is done. What we are trying to do here is, if such a thing happens, that is, if a data set is having only ones or only zeros, we basically go to the, we basically return the next of the iter of the CNT. Now what does this mean? Iter is a function which will create an iterable object, okay, and next is a function which will basically this next is a function which will basically call the or return the next item in the list. So what this iter CNT will just return a list. So if it is having like only ones, it will be just 1, and next of 1 is just 1 itself. And suppose if there are a list of values, suppose 1, 2, 3 like that, and every time the next is called, it will call the it will return the next value in the list. So that is what is happening in this line of code. Now if the when will we return the default class? That happens when either the data frame is empty, that means we have kept on dividing the data frame into sub data frames or sub tables, and ultimately we will have it as empty. At that point in time we can return the default class, or if the attributes are not present. In other words, basically we initially we have 4 attributes. After we consider the first, that is root attribute, we will leave that particular attribute and we will have other 3, and it goes on. So when we have no more attributes left, we can just return the default class. And what is happening in this else? So this is if, elif and else. So this is like to remember the function, to remember the code. So basically ID3 function, there is if, else, if, or if, elif, else structure, and this if is just returning, if it is having only zeros or only 1, it is just returning the next thing in the iterable object, and if it is empty, we are just returning the default class. So this part of the code is done. This is where the actual algorithm is implemented. Now the information is needed here. This is the algorithm. So the algorithm says, in the first step, find the information gain of all the attributes in the data set. So that is what is happening here. Gains is equals to mutual info classif of, we are passing the attribute names and we are passing the target attribute, and this is a thing which, this is just a syntax thing which we need to know. Discrete features is equals to true. It is a part of the syntax for this mutual info classif. Let us not break our heads too much by going into it. Basically what we are doing is, we are just calculating the information gain of the attributes in the data set. Now the first step is done. Next, what does the algorithm say? Choose the attribute with the highest gain as the root node. So now after the gains are returned, we are just creating a list. Now see, gains dot to list. So basically whatever this has returned, we are just ultimately converting it to a list, and we are trying to find the index of maximum of gains. So this line of code, this algorithm, which is in English, is implemented in Python. So the attribute with the highest gain, that is max of gains, is stored in this variable index of max. After that, now we have got the index, but what we need is attribute. So best attribute is equals to attribute names of index of max. So whatever this index is present, we are just accessing that particular index. Now this part of the code is done. What are we doing next? So if we know how to solve the ID3 algorithm by hand, we know that after we have found the root attribute, that is, if in the this is how the decision tree looks. This is how the decision tree looks. Once we have found the root attribute, we neglect or we just ignore that particular attribute and we consider other attributes in the data set. So how are we going to implement that? That is implemented here. So tree is equals to, now best attribute of, we are creating an empty dictionary. Now see, a tree is a dictionary by itself and it is having a key called best attribute and it is having an empty dictionary initially as the value. Why we are doing all this? We can see the output. So the same thing what we get here is kind of represented in the form of a dictionary. We will understand the output later. So in the function, what we are doing is we are creating a variable called tree, and it is basically a dictionary, and it is, in a way you can understand it as a nested dictionary. So this is the key and this is the value. After that, now we have considered the root attribute, but we need the other attributes. So that is implemented here. Remaining attribute names is equals to I for I in attribute names if I is not equals to best. So this is very simple. If for every other attribute which is not equals to best, we are just storing it in this remaining attribute names. Why? So by this time you would have got the clue that okay, now we have got the root attribute, we have the other attributes. So the ID3 function is, see, repeat until done. So what we do once, like for the root attribute, we repeat the same thing. In other words, it is recursive. So we have to call this function again. This ID3 function has to be called again, but we use this remaining attribute names. So that can be understood here. Now we have got the remaining attribute in the form of a list. What we do next is for attribute value comma data subset. Now what is data subset? Data subset is in this df dot, now df dot group by is a thing we have to explore more. By the df is a data frame, and we are grouping by, or that is what we can understand by the name of the function. This is something which we have done in SQL as well. So this is the attribute we have just found, best attribute, best ATTR. So for attribute value comma data set in data frame dot group by of best attribute. In this for loop, basically we are implementing the algorithm again. So here we had formed the subtree. I mean, here we had formed the tree. Here now we are forming the subtree. Subtree is the return variable, and we call the ID3 function. Now the parameters have to be noticed here. Data subset is what we have found, leaving the root attribute, and target attribute remains the same. Target attribute remains the same. We have never changed it. And of course, remaining attribute names, again we have understood that earlier it was attribute names, that is it had all the attributes. Now we have only remaining attribute names, and default class is a last parameter which will have the value none. So basically we are calling the ID3 function again, and we are in a way getting the result further down the tree. So subtree is obtained here. Now observe this line of code. Now this tree is a nested dictionary, as I told. This is the key which we have already created, and we have created one empty value, I mean value which has an empty dictionary. Now since we have got the children, in a way we have got what is present below the root tree, or at any point of time we have got what is present below that particular level. So subtree is now subtree now has to be appended to this tree. Now or in a way it has to be inserted. So tree of best attribute of attribute value. So what is attribute value? Now whatever we have found, that is for this is Sunny, for attribute is outlook for a given attribute value. Now this has to be understood. For a given attribute value, what is the tree below? So for Sunny it has a specific tree, for overcast it has a specific tree, and for value rain it has a specific tree. That is what is happening here for attribute value comma data set in df dot group by. So remembering this output will kind of guide us how to write the program. So tree of best attribute of attribute value. So tree of, this is the tree of best attribute value. Suppose we have found outlook initially. This is best attribute. Attribute value is Sunny in the first case, and it will whatever is a subtree found, it will be inserted. Next attribute value will become overcast, whatever subtree is there, it will be inserted. And next the attribute value become rain, and subtree whatever is present, it will be inserted. Now this happens, it is recursive function, ID3 is recursive function, it is called, and ultimately we have to return the tree. Now the algorithm, the implementation of the algorithm is understood. This was all in the algorithm, so this is no more required. We have understood the function. Now ID3 function is well understood. Now the program is almost done, except a little thing we need to explore by understanding a little bit here. Now this is very easy. df is a data frame, we are creating one variable to read the CSV file, that is train10s CSV file. After we have read, there is a clue which we can kind of remember. Wherever we are kind of accessing the attribute names, there we usually process it as a pandas data frame. So that is one guiding factor we can remember. So here also we are accessing the attribute names. So it is a pandas data frame, df.columns.toList. So column names, it is just we are just finding here attribute names, and the same is list of attribute names. So it is basically printed here, this outlook, temperature, humidity, when it is printed. Now what is happening in this for loop? This is something which we need to understand. Now what is now the decision tree can be understood later. We will just minimize this. Now this is the data set we are processing. Okay. Now train10s is this data set, train10s.csv. Now you can see that it has values like sunny, for example outlook has sunny, overcast, rain, temperature is hot, mild, cool, and things like that. But here in the output we are saying that the normal English variables are normal English names are replaced by numerical values. So where is this implemented? So that is happening in here. So for column name in df dot, now this is something which you need to remember, the proper exact reason for why this is the way to do it can be explored from online, but this is something which you can remember. The logic what it is doing is, it is basically, in a way, it is basically creating the equivalent mathematical values. In other words, for example, sunny is becoming 0, overcast is becoming 1, and rain is becoming 2. So that is for outlook. Similarly for temperature, it has hot, mild, and cool. So hot is 0, mild is 1, and cool is 2. Similarly for humidity, it has only two types of values, high and normal. So high is 0, normal is 1. Wind has two types of values, again 0, 1. Lateness, no s is becoming 0, 1. So this is done here. So there is a function called as factorize, which is implementing all this. So this two lines of code has to be remembered, and this is very important. If this is not done, the ID3 function will not work, because it is basically working, or this ID3 function is working on numerical values, not this English names. That is why these two lines are very important. So we have in a way converted the data set to this format. So we are just printing it. So after this list of attribute names are printed, we are printing the data frame itself. Now this is the data frame. Now this is understood. Print df is understood. We are calling the ID3 function for the first time. Tree is equals to ID3 of. We are passing the entire data frame. We are passing the plate.ns as the target attribute, and attribute names is the column names. That is 1, 2, 3, 4 column names are passed in this attribute names. So this will basically return a tree, and this is just a print statement. Pprint is, as I told, it is pprint means pretty print. It has its own application. More can be explored online by learning more about pretty print. In a way, we are just calling this, instead of print, we are calling pprint, that is pretty print, for tree, which will result in an output which looks something like this. Now we will trace the output just a little while later. Now the entire program is understood. So the packages are imported, and the data frame is read, and we are kind of converting the data set to this format, where we are just representing it as numbers, and we are calling the ID3 function. ID3 function is called. It is a recursive function. The ID3 function is explained and it is understood. So it ultimately it will return a tree. It will be stored here in this variable called tree, and we are printing it. Now let us understand the output and we will conclude. So this is the output which we get while solving on paper. So the same can be correlated here. Now outlook has three values: sunny, overcast and rain. Sunny means 0. So when outlook is sunny, we are checking humidity. So humidity is considered. When humidity is high, so you can correlate here. Humidity is high, so humidity is 0. When humidity is 0, we get the output value as no. Output value no is represented as 0. So output value is no. And when humidity is normal, that if it is 1, output value is also 1. Now this is implemented or represented here. Now when outlook is 0, we have done what this part of the code. I mean this part of the decision tree. When outlook is 1, you can see that it is ending here itself. When it is 1, it is yes. That means it is 1. So this is one subtree. This is between these two commas. You can see that 1 is to 1. This is one subtree. And when it is rain, that is the third possible value of outlook. This is 0, 1 and 2. So when it is rain, what we are doing, we are basically finding the values for wind. So an outlook is having the value rain, that is 2. We will evaluate the wind attribute. When wind is having 0, that is strong, so that can be correlated here. When wind is strong, it is no. So when wind is strong, it is no, and when wind is weak is 0. When wind is weak, it is 1. So this decision tree is written in this form of a dictionary here. Now this will conclude the program. If we are asked to try a given example on the decision tree, the program doesn't implement it, but the problem statement says that apply the decision tree for an example if needed. So suppose they are given something like this. Suppose you are asked to evaluate the output column for this particular row. So you just apply this decision tree. So here it is outlook is rain. Outlook is rain means it is, you have to come here. Outlook is 2, and so then you have to see the value for wind. So when outlook is rain, you just see the value for wind. Wind is strong. Strong has the value 1. So if wind is strong, it will finally evaluate it to 0. 0 means no. So it is working fine. So decision tree has evaluated the parameters, and ultimately it is returning a correct decision tree. So this is the shorter program which can be understood and learned for program number 4 of Artificial Intelligence and Machine Learning Laboratory of VTU. Thank you.